There's this incredible scene playing out right now with the semiconductor world. Imagine this. The Dutch government, under immense pressure, decides to rescue one of its crown jewels, a chip maker called Nexperia. They invoke this dusty Cold War-era law, seize control of the headquarters, suspend the Chinese CEO, and install their own managers. It's a bold, decisive move.
Really bold.
You can almost picture the press conference, a sense of relief, of securing a critical European asset from Chinese control. It feels like a victory. They've protected the company, the jobs, the know-how.
Whatever they thought.
Exactly. But then you look just a little bit closer, and the whole picture starts to blur. While they were seizing the headquarters in the Netherlands, a memo was going around Nexperia's factories in China.
Which, crucially, make up, what, 80% of its total capacity?
80%. That memo basically told employees to ignore the new Dutch bosses.
Just disregard them.
And then comes the punchline, the part that makes this so fascinating. Turns out, all the company's new product designs, they're only compatible with those Chinese factories. The old European plants. They're running on 6-inch wafers.
Ancient tech, relatively speaking.
They physically cannot produce the company's new chips.
Yeah.
It's this logic that's just stunning. The act of saving the company may have been the very thing that severed its head from its body. Welcome back. If that opening didn't just completely grab you, well, I don't know what will. For you listening in, our mission today is really to unpack this Nexperia case.
Yeah.
It's such a perfect, maybe painful, but definitely informative example of this global fracture we're seeing everywhere in the semiconductor world.
It really is.
It's like this divorce, isn't it? Between the design legacy, often still based in places like Europe, and the manufacturing reality, which, let's face it, is overwhelmingly anchored now in Asia, particularly China in this case.
Absolutely.
We're going to explore how a government's, really decisive action to grab control might have ended up securing, well, an empty shell.
Yeah.
And what that actually means for all of us, for global supply chains.
And what's really key here, I think, is understanding where Nexperia fits in the whole semiconductor landscape. Because when most people hear semiconductors, they immediately think, NVIDIA, AMD, the really high-end stuff for computing.
Super fast processors, yeah.
Exactly. Nexperia is completely different. But you could argue, just as critical, maybe even more so in some ways, it's a huge global supplier of power semiconductors.
Okay, power semiconductors, what exactly are those?
These are the real workhorse components. Think diodes, transistors, and especially MOSFETs. That's metal oxide semiconductor field effect transistors.
Right, so not the brain of the computer or the car, but more like the muscles, the circulatory system managing all the electricity.
That's a great analogy. Yeah, they manage every flow of power. They're absolutely indispensable. You find them in everything from your car's steering and braking systems to industrial machinery. And really importantly now, they're vital components in green tech, especially in electric vehicle power management systems.
Ah, okay. So if Nexperia production stops,
the auto sector feels it immediately, like first and hardest. And we absolutely have to remember the context here. Nexperia, despite its, long Dutch history.
Right, it sounds very European.
It does, but it was fully acquired by this massive Chinese conglomerate WingTech Technology back in 2019. That acquisition, it's the essential backdrop for everything that's happening now.
Okay, right, that context is key. So let's get into the drama then, this Dutch intervention, because it really does sound like something out of a movie. October 2025.
Yeah, the timing is important.
And it starts with this quote-unquote rescue by the Dutch government. And you said it wasn't just the normal regulatory stuff. This was unprecedented.
Totally unprecedented. They seized control of the headquarters using something called the Goods Availability Act.
Goods Availability Act. Never heard of it.
Exactly. And that law itself is it's a museum piece almost. It's not some modern corporate security law designed for this kind of situation. It is a genuine relic from the Cold War. Emergency planning stuff. Enacted way back in 1952.
Wow, 1952.
Yeah, and for decades, it just sat there, collecting dust on the books. It had literally never been used against an actual operating company before. So pulling that law out, it signals just how extremely serious the government thought the threat was.
That's a huge point.
Right.
Why use that law? A Cold War emergency measure. Couldn't they have used, standard corporate governance rules? Was invoking the Cold War angle meant to send a specific message? Maybe to Beijing? with the rest of the world?
I think it absolutely was meant to signal maximum severity. Look, standard corporate laws, they might allow for fines, maybe forcing some restructuring, but they don't typically allow for the immediate forced seizure of corporate control like this.
Ah, okay. So this is about speed and control.
Exactly. Now, the official reason they gave, the public justification, was very specific. They cited serious governance failures and, importantly, a threat to Europe's economic security.
Governance failures, like what?
Well, they suspended the CEO at the time, Zhang Suijing, and the accusation was that he used his position to arrange deals where Nexperia bought overpriced components from other companies, companies that were struggling financially, and that he personally had a stake in. So that provided the sort of clean internal corporate reason for the government to step in.
Right. That sounds like a legitimate corporate governance issue on the surface, but the timing, invoking a 1952 emergency law right then, it makes you wonder, doesn't it? Was this really just about cleaning up internal issues, or was there something bigger pushing them?
Oh, absolutely. There was a huge geopolitical storm brewing right at that moment. And that timing really forces the critical question. Was this purely about fixing alleged malpractice inside the company? Or was the timing, maybe even the action itself, strategically forced by outside pressures?
Okay, so what were those outside pressures?
Well, the context strongly suggests it was the latter. Washington, the U.S. government, had been steadily ramping up pressure. Wing Tech, the parent company, remember?
Right, the Chinese conglomerate.
They had already been placed on the U.S. entity list. That was back in December 2024.
And the entity list, just to remind everyone, that's basically a blacklist, right? It cuts companies off from certain U.S. technologies, software, services.
Right. It's a serious restriction. But things got much, much tighter just before the Dutch made their move. On September 29th, so just weeks before the seizure, the U.S. expanded something called its affiliates rule. And this expansion was the real game changer here. It automatically applied the same U.S. export restrictions to any company that was 50% or more owned by a firm already on the entity list.
So Wing Tech was on the list.
And Wing Tech owned Nexperia 100%.
Nexperia suddenly fell under those same U.S. restrictions, just like that.
Just like that. Overnight, Nexperia was in immediate danger of being cut off from potentially vital American inputs, maybe design tools, maybe specific software, things it might need to operate.
Wow. Okay, so the Dutch government, acting in October, they were likely feeling immense pressure, essentially being forced, maybe, to decouple Nexperia from Wing Tech to prevent the whole company from being choked by these new U.S. sanctions.
That seems highly plausible.
They frame it publicly as a governance issue, which might have been true to some extent.
Sure.
But the timing and the method perfectly align with Washington's bigger strategy, which was all about decoupling critical tech supply chains from China.
Exactly. You could see the Dutch action as a very rapid, very aggressive move to align with that decoupling strategy. Maybe they hoped it would protect Nexperia's ability to keep operating in Western markets free from those U.S. sanctions.
A bold move, as we said.
Extremely bold. But that boldness was met with an equally swift and frankly brutally effective countermove from Beijing.
Right. The moment the Dutch invoked that Cold War law, suspended the CEO, China's response wasn't slow or diplomatic, was it?
Not at all. It wasn't about talks or negotiations. It was, like you said in the opening, an economic amputation.
Yeah.
Beijing immediately imposed an export ban specifically on Nexperia's own China-based operations.
Blocking exports from Nexperia China.
Yes. Halting shipments of essential standard automotive chips, the kind they make huge volumes of from those massive Chinese facilities. Given the scale we talked about, 80% of capacity.
That's huge.
This instantly immobilized nearly half of Nexperia's entire global production capacity for those specific crucial components. Just shut it off.
And crucially, this wasn't just government squabbling. It ripped the company itself apart, right? A kind of internal schism.
Yes, the internal corporate fracture was, I think, unprecedented. Nexperia's China department, the management there, issued this really sharp directive to all the local employees.
What did it say?
It basically told them to disregard instructions coming from the newly installed Dutch headquarters.
Wow.
And explicitly told them to follow the orders of the domestic Chinese management instead. They flat out asserted that Nexperia is fundamentally a Chinese company with operations rooted in China.
They were essentially saying, you might own the mailbox in the Netherlands, but we own the factories, the people, the actual production.
That's exactly it. The legal control the Dutch government asserted in Europe was immediately nullified by the operational reality on the ground in Asia.
That's the core tension, isn't it? They seized the head office, and the body immediately declared independence. Okay, so now we need to get into the technical heart of this story, the aha moment from the opening. Let's do that deep dive. Why exactly are the European assets, the factories in the Netherlands and Germany, why are they now functionally irrelevant?
Yeah.
Regardless of who legally owns the HQ.
Right, and the irrelevance really comes down to a fundamental technological choice, a path taken after that 2019 WingTech acquisition. It's what we can call the design lock-in.
Design lock-in, okay.
When WingTech took over, they didn't just maintain the status quo, they poured huge amounts of capital into scaling up capacity. But, and this is the critical part, they focused that investment almost entirely on modern, high-volume manufacturing standards.
Which means moving to bigger wafers.
Exactly. It means that every significant new product design, all the new power devices Nexperia developed over the last, say, 5 or 6 years, was optimized for and taped out on.
Taped out meaning like sent to manufacturing.
Precisely. Put into the manufacturing flow. And they were taped out exclusively on the Chinese 12-inch wafer lines. That's 300-millimeter wafers.
Okay, 12-inch in China.
And the core design files themselves, the blueprints, the GDS files, they were developed hand-in-hand with the process engineers in those Chinese fabs. And they are now fully controlled by the domestic Chinese design team.
And the old European facilities, the ones the Dutch government now technically controls, in the Netherlands, Germany, the UK.
They're running on the old 6-inch wafers, 150 millimeter. You're literally talking about 2 different generations of semiconductor manufacturing technology.
You can't just run a 12-inch design on a 6-inch line.
Absolutely not. A design that's optimized for the specific physics, the layout, the economics of a 12-inch wafer line, which gives you huge economies of scale and allows for certain device geometries. You simply cannot load that design onto a 6-inch manufacturing line. It's a fundamental physical incompatibility.
So even if the Dutch HQ somehow got their hands on the new design files, which seems unlikely given the internal memo.
Right, even if they did, the manufacturing equipment they actually possess in Europe, it physically cannot handle those designs, full stop.
So the only way would be to
rip out and replace almost everything in those European fabs, upgrade them entirely to 12-inch lines. The cost would be astronomical billions. And it would take years they probably don't have given the market pressure.
Let's dig into that economics a bit more. Why the big push to 12-inch anyway? It's not just about being new, is it?
No, it's fundamentally about cost per chip or cost per die. Think about it. A 12-inch wafer has more than 4 times the surface area of a 6-inch wafer.
4 times the real estate.
Right. But processing one wafer, regardless of size, takes roughly the same amount of time and resources, the etching, the deposition, all those steps. So the number of usable chips or dies you get from that much larger 12-inch wafer is drastically higher.
So your manufacturing cost for each individual chip plummets.
Exactly. And that is absolutely essential when you're making high-volume, cost-sensitive components like power semiconductors, especially for the incredibly competitive automotive market. That relentless optimization for high volume and low cost, it has entirely migrated to the 12-inch lines in Asia.
Okay, so there's a massive capital barrier, the sheer cost of upgrading. But you mentioned the technical lock-in goes even deeper than just the wafer size, especially for these critical automotive chips like MOSFETs.
Yes, it does. And this, I think, is the technical detail that really seals the operational, well, you'd say victory for the Chinese side in this whole affair. Power devices, especially MOSFETs, unlike some simpler logic chips, are intensely dependent on something called the match rate.
Match rate?
Yeah, the match rate between the very specific design parameters of the chip and the equally specific characteristics of the production line it's made on the process engineering side.
Okay, explain that relationship. Why can't they just, copy the process settings somewhere else if they have the design?
Because it's not like just following a recipe. The manufacturing parameters themselves, things like the exact shape, the trench profile they etch into the silicon, or the precise injection dose of chemicals used to dope the silicon, or the specific temperatures used for annealing, all these things have to be meticulously, painstakingly tuned to match the chip's design.
Tuned how?
Tuned to achieve the optimal electrical performance, the reliability, the stability, the efficiency that the industry often calls RSP, reliability and stability performance. And this tuning isn't just theoretical work done on a computer. No, it requires really long-term, hands-on collaboration. Sources suggest it takes typically 1 to 2 years.
Years?
Yes, years, where the R&D team who designed the chip works iteratively back and forth with the process engineering team right there on the factory floor. They're constantly testing batches, tweaking parameters, refining the process until they get the exact performance characteristics demanded by the customer, say, for a high-voltage system in a new electric car.
Okay, so it's not just like emailing a blueprint. It's like needing the master chef, their specific unique kitchen setup, and the giant 12-inch oven they've perfected over years, all working together in perfect harmony. You can't just replicate that easily.
That's a perfect analogy, exactly. The real know-how isn't just the GDS design file. It's that deep, symbiotic relationship that's been built up over years between the designers and the specific Chinese fabs, like the Dingtai facilities and Wingtech's own lines, which have been running these particular 12-inch processes day in, day out.
So even if the Dutch HQ got the design files today.
Right, and they took them to, say, a major Western foundry, a company like Global Foundries or someone.
Yeah.
It would likely take that foundry a year, maybe 2 years, just to tune their processes to reliably achieve the same RSP, the same performance and reliability that Nexperia's big automotive customers absolutely depend on and have already certified. This deep process design matching is the real operational moat here. It's something geopolitical maneuvers just can't cross quickly or easily.
That technical lock-in is really profound. Okay, so given that, let's put some numbers on this massive shift in manufacturing capacity. We heard the figure 80% of Nexperia's total wafer capacity is now domestic in China. How does that actually break down? How does that capacity compare to what's left in Europe?
The numbers really tell the story of the strategic focus after the Wingtech acquisition. The capacity built up in China is just massive, and it's all optimized for those modern 12-inch wafers. For example, you have the Dingtai Chongqing facility that handles roughly 30,000 12-inch wafers every month.
30,000 12-inch wafers a month.
Okay. Then there's the Dingtai Lengang facility near Shanghai. That one's even bigger and focused on the more advanced trench MOSFETs. Estimates put its capacity at around 60,000 12-inch wafers per month.
60,000. So between just those two, that's nearly 100,000 of these advanced 12-inch wafers every single month.
Right. Now, if you want to compare apples to apples with the older European fabs, you have to convert that 12-inch capacity into the older 6-inch equivalent. Because of the area difference, those 90,000 12-inch wafers are roughly equivalent to making 360,000 6-inch wafers per month, just in China.
360,000 6-inch equivalents in China. Okay, now compare that to Europe. What's left in the Netherlands, Germany, the UK?
Well, the remaining European footprint, those older plants running 6-inch lines, their combined capacity, if you're being generous, is maybe estimated at around 100,000 6-inch equivalent wafers per month.
So only 100,000 total in Europe versus 360,000 equivalent just from those two big fabs in China.
Exactly. And realistically, those older European fabs are probably running less efficiently too. So the sheer scale, the modernity, the cost efficiency of the Chinese facilities, it means the European footprint has been strategically sidelined when it comes to high volume, next generation chip manufacturing for Nexperia. It's just not comparable.
That technical reality, that stark difference in capacity, really sets the stage for understanding the strategic implications, doesn't it? Let's maybe shift gears a bit from the political conflict and look at how Wingtech's ownership actually helped China's own domestic capabilities. This is about what was gained technologically inside China, not just what Europe might have lost politically.
Yes, and that's such a vital perspective to include, because when a lot of Western analysis focuses only on the geopolitical friction, the trade wars, the decoupling, it often completely misses the profound technological leap that this acquisition actually facilitated inside China.
How so?
Well, I came across this really interesting report detailing the experience of a young Chinese process engineer, let's call him Li, working in Shanghai. And for engineers like him, the Wingtech acquisition wasn't seen as some hostile foreign takeover. It felt more like the floodgates of capital and high-level European design knowledge had finally swung open for them.
Okay, so it wasn't just about moving existing production. What did that mean specifically for him and his team? What changed?
It meant a direct, really aggressive push into developing cutting-edge materials and processes right there in China. Lai, for instance, was recruited specifically to work at that new 300mm power semiconductor fab in Lingyang we mentioned.
Yeah.
His job was to help pioneer gallium nitride processes, GaN.
Gallium nitride. GaN, that's seen as the next big thing in power electronics, right? More efficient, smaller components.
Exactly. It allows for much higher efficiency, higher frequencies, and smaller, lighter power systems.
Right.
It's absolutely crucial for things like modern 5G base stations, advanced server power supplies, and especially for making electric vehicles lighter and more efficient.
So this was a huge jump in technological capability for them. Was GaN something Nexperia was already doing aggressively before WingTech bought them? Or was this shift really driven by the new Chinese ownership and their focus on those big 12-inch lines?
It seems the capital injection and the strategic focus under WingTech really turbocharged this shift. While Nexperia certainly had the core European design expertise in power devices, rapidly scaling up GaN production on high-volume 12-inch wafers, that requires immense strategic long-term investment, and WingTech provided that.
So for engineers like Lin.
For engineers like Lee, it felt like they'd gone from working in an environment that was maybe, in his words, 10 years behind the global cutting edge to suddenly being right at the forefront, driving core component innovation for China's own massive and rapidly growing electric vehicle revolution.
That's a powerful narrative.
It is. So the acquisition wasn't just about shifting where existing chips were made. It was about internalizing, mastering, and actually advancing sophisticated process knowledge within China, building up this robust, self-reliant foundation for future tech leadership in these critical power components.
That kind of internal motivation, that sense of building something new, it really highlights the strategic resilience we saw when they were suddenly cut off from the Dutch HQ, doesn't it? Thinking about the reaction on the factory floors, say in the Dongguan facility.
Absolutely. When the news came through that the European government had seized the parent company, the local staff, the local management, they didn't really see it through a European legal lens. They felt a profound sense of external disruption to their operations.
They felt like they were the ones being cut loose, maybe.
Quite possibly. Their focus wasn't on Dutch corporate law. It was purely on operational continuity, keeping the factory running, keeping people employed, fulfilling orders. And the result was this really remarkable, very rapid demonstration of strategic autonomy.
What did they do?
Well, reports indicate that local management implemented this swift, almost defiant pivot. They immediately started working to secure new domestic orders to fill any potential gaps left by disruptions in European demand or logistics.
Smart. Keep the lines busy.
Exactly. And critically, they also reportedly moved to change payment terms for many transactions from US dollars to Chinese yuan, the RMB.
Insulating themselves from currency fluctuations and potential financial sanctions related to the US dollar system.
Precisely. It shows that strategic autonomy isn't just some high-level government policy paper. It's being actively executed in real time by factory managers on the ground. They didn't just stop production and wait for instructions from a headquarters that had just been taken over thousands of miles away. They aggressively reoriented the business to keep the machines running and prove they could be self-sufficient.
They were cut off, but they showed they could maintain and even advance critical production capabilities all on their own, domestically.
Demonstrably so, yes.
Which, of course, leads to some pretty pointed criticism being aimed back at the original Dutch move itself. You have to ask, was this seizure really a strategic win for Europe in the long run?
Well, the immediate reaction from industry veterans, people who know this sector inside out, and from analysts, it suggests that, at best, it was what they call a Pyrrhic victory. You know, winning the battle, but losing the war.
Who was saying that?
The former CEO of Nexperia itself, Franz Schieper, was quoted publicly stating what seemed obvious from the operational side. Beijing simply has the upper hand. And I saw a political commentator, Arnaud Bertrand, call the move profoundly dumb.
Strong words.
His argument was that rather than securing a valuable asset for Europe, the seizure actually risked killing the asset entirely by splitting it, and in doing so, badly harming the continent's own automotive and industrial sectors that rely on those chips.
And the core reason for that harsh assessment is pretty clear now, isn't it?
Yeah.
If you seize the legal entity, the nameplate on the door in the Netherlands.
Right.
But the vast majority of your actual production capacity, all your next-generation technology, and the critical process know-how are physically and technically locked into the part of the company that is now ignoring you. What have you actually seized?
You've seized an empty building with some administrative staff. That's exactly the point being made. The European strategy, perhaps understandably focused on legal control and ownership, often seems to overlook the sunk costs, the accumulated expertise, and the sheer time required to replicate advanced manufacturing capacity.
It's not just flipping a switch.
Not even close. The cost, as we said, of trying to retrofit those old 6-inch European fabs to modern 12-inch standards, even if you could somehow get the designs and replicate the process match, would run into the billions. It would take maybe half a decade. And all that time, you'd be facing intense cost competition from the already optimized high-volume Asian capacity.
So this whole Western push for technological sovereignty, things like the big EU Chips Act.
It runs headlong into this reality. The Nexperia case shows that the deeply integrated, highly competitive manufacturing infrastructure already established in Asia has immense inertia. Operational reality, scale, and cost efficiency often trump legal control of a distant holding company.
Okay, so summing up, we have a corporate seizure in the Netherlands, met by a declaration of operational independence in China, underpinned by deep technical lock-in that basically renders the European assets unable to produce the company's key new products. So who gets hit first and hardest by this immediate fracture? It has to be the global automakers, right? They rely on these chips every day.
Absolutely. The shockwave hits them almost instantly because Nexperia isn't some niche supplier. They are a massive, high-volume, deeply entrenched supplier selling, roughly 60% of their entire output directly into the automotive supply chain. We're talking major global players: Volkswagen, Toyota, BMW, Mercedes-Benz.
The giants.
The giants. So when potentially 80% of your global wafer capacity located in China is suddenly immobilized by an export ban affecting finished goods, the global auto industry moves from just being concerned to being in a full-blown crisis practically overnight.
But hold on, these are huge car companies. Surely they have backup suppliers.
Yeah.
Can't they just switch to other big power chip makers like Texas Instruments or on Semiconductor, maybe Diodes Incorporated? They make similar standard power chips, don't they?
But the term standard chips can be really deceptive, especially in the automotive world. And this is the absolute crucial barrier to just switching suppliers quickly. Nexperia specializes in mature, proven technologies. Yes, you could call them legacy chips in some cases, but these specific chips carry incredibly stringent automotive qualification certifications. And these are absolutely non-negotiable for safety, reliability, and regulatory approval in cars.
Certifications like?
Things like AEC Q100, which is for integrated circuits, and AEC Q101 for discrete semiconductor devices like MOSFETs and diodes.
Okay, AEC Q100, Q101. What do those certifications actually involve? What makes them such a high bar?
Oh, they involve months and months of really rigorous, highly specialized testing. We're talking about pushing these components to their absolute limits under demanding conditions. Testing across extreme operating temperature ranges, from freezing cold to scorching heat, repeated thermal cycling back and forth, intense vibration tests, shock resistance tests simulating potholes and collisions, and long-term lifetime stability testing under electrical stress.
Wow, okay.
An AEC Q101 qualified MOSFET, for example, has basically been proven through testing to withstand the incredibly brutal environment under the hood of a car reliably for years and years. You absolutely cannot just unplug an Nexperia chip and plug in a different brand's chip that hasn't gone through that exact same documented gauntlet.
So switching suppliers isn't just about matching the technical specs on a datasheet.
Not even close. It requires the automakers, or more likely their Tier 1 suppliers, to go through the entire homologation process all over again for the new component.
Homologation?
Yeah.
That sounds serious.
It is. It's the formal, often months-long validation and recertification process needed to approve any new component for use in an existing vehicle system or assembly, especially anything safety-critical like braking, steering, or powertrain control. Automakers simply cannot compress those essential reliability and safety standards into just days or weeks, no matter how urgent the supply situation is.
So Nexperia's chips, even the standard ones, are effectively irreplaceable in the short to medium term because of these certifications.
That's the crux of it, yes.
And you mentioned Tier 1 suppliers. The dependency gets even more complicated, right?
Yeah.
It's nested. Thinking about our imaginary supply chain manager, Marcus.
Right. Poor Marcus. He isn't just waiting for a delivery of individual Nexperia chips in little plastic reels. That's not how it works for the final car assembly line.
No.
No. Nexperia chips are typically embedded components. They're soldered onto complex printed circuit boards inside pre-assembled electronic control units, ECUs, that are designed, built, and supplied by the massive Tier 1 automotive suppliers. Companies like Bosch, Continental, Denso, Magna.
Ah, okay. So the car company buys a whole pre-built module from Bosch, for example, and that module has the Nexperia chip already inside it, designed in.
Exactly. So if BMW or VW suddenly wanted to swap out an Nexperia MOSFET because they can't get it anymore, it's not their decision alone. The Tier 1 supplier, Bosch, in your example, would potentially have to redesign their entire ECU module around a new alternative chip.
Which would mean?
It would mean the entire redesigned module from Bosch, incorporating the new chip, would have to go through the whole lengthy automotive qualification and homologation process all over again just to be approved for use in the car.
That sounds like adding months, maybe even a year to the timeline, a logistical nightmare.
It's a massive headache. So Marcus isn't just facing a shortage of one tiny component. He's facing a complete potential halt in the supply of these complex, critical Tier 1 subassemblies that have already been designed, tested, validated, and certified around the specific Nexperia components that are now suddenly stuck in China.
And there's one final twist, isn't there? A final, maybe ultimate dependency that really proves how deeply integrated this whole global supply chain still is, despite all the talk of decoupling. The fact that even the wafers made in Europe still rely on Asia.
Yes. This is the critical point that becomes the absolute immediate bottleneck. Even the silicon wafers that are successfully manufactured in Nexperia's remaining European facilities, the ones in Hamburg, Germany, for example, they are not finished products ready to be shipped to Bosch or Denso. They're just patterned silicon disks. They must be sent, typically, to specialized infrastructure, mostly located in Asia. Think of advanced packaging and testing facilities, maybe in Guangdong province in China or elsewhere in the region.
For what?
For the absolutely essential, irreplaceable final steps. Cutting the individual chips, dies from the wafer, testing each one rigorously, and then packaging them into the final component form factor that can actually be soldered onto a circuit board.
And the Chinese export ban.
Yep.
It blocks that final step too.
It potentially blocks the finished packaged product from leaving those specialized facilities. So you could have a perfectly good wafer, manufactured entirely in Germany, sitting there, but without access to that specialized high-volume Asian cutting, testing, and packaging infrastructure, the back-end processing that wafer is effectively useless to the global automotive supply chain.
So it chokes off the supply completely, even for European-made silicon, threatening production lines for, say, new EV models that desperately need those specific packaged power chips.
Precisely. It hits everything that relies on that final packaging step being done where the ban is in effect.
Okay, so what's the immediate timeline look like? When does this crisis actually hit the car factory assembly lines? How long do they have?
The timeline is frighteningly short. The European Automobile Manufacturers Association, ACEA, they put out a statement almost immediately. They were very clear. Existing stockpiles of these crucial chips, the buffer inventory in the system, would likely last for only several weeks at most.
Weeks, not months.
Weeks. And we started seeing the emergency responses straight away. Volkswagen, for example, announced they were preparing internal task forces to manage the crisis. They stated publicly they couldn't rule out short-term production impacts. They specifically mentioned the potential need to suspend production of key models, like the Golf, at their huge main plant in Wolfsburg.
So the dominoes were already starting to fall almost immediately.
Absolutely. This wasn't a distant forecast. It was an immediate unfolding crisis.
And presumably this isn't just a European problem, given global supply chains.
Not at all. It's completely global. The Alliance for Automotive Innovation, which represents automakers in the U.S., also issued urgent warnings. They projected that American auto plants could start facing production impacts potentially as soon as November, following the October seizure.
Wow.
It just proves yet again how incredibly tightly coupled these supply lines for essential, albeit sometimes legacy, chips remain. Regardless of all the geopolitical ambitions for decoupling and reshoring, the operational reality is still one of deep interdependence.
This whole Nexperia story, then, it's just a masterclass in modern geopolitical risk, isn't it? It proves, maybe more clearly than anything else recently, that you can win the legal battle for control of the corporate nameplate.
Right, get the keys to the HQ.
But completely lose the operational war for the actual manufacturing capacity and the know-how. They seized the head, like we said in the opening, and that very act just severed it completely from the productive body.
That really is the definitive takeaway here, I think. The legal seizure of the headquarters using that dramatic, dusty Cold War law, it turned out to be almost entirely meaningless in any practical operational sense for securing the company's future value.
Because the real value had already moved.
Exactly. The true value of Nexperia today, the specialized process knowledge for power devices, the massive, cost-effective 12-inch wafer capacity, the emerging technological leadership in areas like gallium nitride that had already shifted, it had become deeply integrated with the operations, the engineers, and the fabs in China. The Dutch government, you could argue, won custody of an administrative office block in Nijmegen, not the actual manufacturing engine that drives the global business and holds the key to its future products.
So if we try to connect this specific Nexperia case to the broader strategic picture, we know the European Union launched its big EU Chips Act with the ambitious goal of reaching 20% of global semiconductor market share by 2030, trying to build up technological sovereignty. What does this Nexperia fracture tell us about the real-world viability of that ambition?
Well, it certainly tells us that the pursuit of technological sovereignty, however necessary it might seem politically, faces an enormous structural reality check on the ground. The EU's 20% goal is incredibly ambitious. Nexperia highlights just how difficult, expensive, and time-consuming it is to overcome the existing advantages in cost, scale, accumulated expertise, and supply chain integration that are already firmly established, particularly in Asia.
So is 20% realistic?
It's looking very challenging. While the 20% target is the headline goal, I've seen internal projections and analyses suggesting that even with the CHIPS Act funding, the EU might realistically achieve a more modest market share, maybe somewhere around 11.7% by 2030.
Still an increase, but far short of the headline goal.
Exactly. And Nexperia really underscores why. It shows that this deep operational integration in Asia, built up over decades, is the current structural reality. And it is extremely difficult, takes a very long time, and is exponentially costly to try and rip that apart and successfully replicate or rebuild that kind of resilient, competitive manufacturing infrastructure domestically from scratch.
So pulling it all together then, the Nexperia saga really does seem to illustrate this fundamental reckoning that's happening for global industry right now. That whole model we lived with for maybe the last 3 decades just in time, globalized manufacturing, optimized purely for cost efficiency above all else.
Lean manufacturing taken to the extreme.
That model just may no longer be viable, not in an era like ours, which is increasingly defined by state interventions, by intense technology competition between nations, and by these sudden, politically driven fractures in corporate control. This seems like the new, unavoidable structural risk that companies everywhere now have to figure out how to navigate.